Hi, hello. Hey guys. Hello, hello. Is anyone able to hear me? Okay, right, okay. So whatever I'm saying, I feel like this is the first time I'm streaming. So whatever I'm saying, it is a little laggy, right? Okay. Um, I think I'll start today's class. Okay, so my name is Sriram, and I've been working as a professional software engineer from 2.5 years, more than 2.5 years. It's almost 2 years, 8 months, right? And yeah, I also teach during my free time, and uh, yeah, I guess we can start, right? So I'm gonna close this and then I'm gonna start this, right? Cool. Um, yeah. You guys are comfortable with English and everything, right? Okay. Yeah. So I'm gonna start. Um, right. Um, okay. So today's agenda would be, yeah. First of all, am I audible? Hello, guys. Just let me just ask you whether I'm audible or not. Yes, I'm audible. Yes. Okay. Cool. So cool. Okay. Nice. Okay. Yeah. So let us just start with the lecture if it's okay with you guys, right? Okay. Yeah. Um, so today we are going to cover very basics of Java, right? And these basics generally would be covering, intro aspect of it, right? We will cover the intro. We will cover what is JDK and JRE. We will also cover language rules. We will cover, data types. We'll cover operate. If time permits, we'll cover operators, right? And so we will go a little in depth in most of the topics that we are going to cover today, right? And let's start. Cool. Yeah. So, okay, let's even before going and looking into what is Java, right? Let's see what happened when, what happened when we used to use, C and C++ and all of those kind of things, all of those kind of languages, right? Um, so, so even before Java, so what happened before Java? Before Java, we used to use C, right? In C, we generally write the code as follows. Basically, we write like a hash include, right? And then stdio dot h, and then we write like a main function, and then we write printf, right? And then like something like percentile d, and then maybe 10, right? And then we write something like this, and this code, right, this code looks okay and nice. So what we do is we give this code to basically a compiler, which is GNU's not C, GCC compiler. So this is a C compiler, right? When we give it to a compiler, what it does is it generally just gives you a machine code basically, and this machine code is all zeros and ones. Okay, so that is what we used to do previously, right? Now, what the problem with this would be that, let's say if I'm using a system, right? If I'm using, one second. Yeah. So let's say if I'm using, let's say system A, right? If I'm using system A and this is a Mac, right? And it works on like Intel, right? And let's say I'm using a system B, right? And this is like a Linux system, right? And it uses AMD. like a processor, right? So the problem with this, the problem would be that hello, is my iPad screen visible? My iPad screen is not visible? Oh, very sorry, very sorry. One second, one second. Huh, okay. Yeah, one second, one second. Yeah. Is my screen visible now? iPad screen. Okay, okay, okay. Um, Let me check it out. Is it fully visible, guys? Let it come. Yes, now it is visible, right? Cool, 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 cool. Sorry. I'll just repeat quickly what I said. Right? We are going to cover intro to Java, JDK, JRE today in this class, data types, and if time permits, I'll cover operators. Okay? Right? Only if time permits. Right? So we'll go a little bit into depth in all of these kind of things. Right? And even before Java, we had our handy dandy C and also C++ and all of these kind of languages, right? So the problem, so in general, what we the way we write this the code in this language is we use like hash include and then main and then printf and all of these kind of things, right? And we give it to GCC, and then GCC will give you a .exe file basically, right? We will get a, let's say if this the function, sorry, the file name, if let's say it is hello.c, right? We will get hello.exe here, right? Or in Linux you get hello.out, something like that. You get an executable file, right? If you get an executable file, this executable file is in general, it will be something like zeros and ones, right? This will be only understandable by your CPU, your machine. So the problem with this is that your GCC, now your GCC, right, will generate depending on the system, right? It will generate the executable depending on the system, executable changes. That is the first and foremost understanding you need to take from this. Depending on the system, the executable changes, right? If the executable changes, what happens is that if I get a .exe file in this particular system and I get a .exe file in this particular system, right? Let's say I get a.exe and b.exe in this system, right? In system, sorry, let's just name it properly, right? We'll just do a.exe and b.exe in this, right? So this file you cannot run in this system, and this particular file you cannot run in this system, right? And also there are multiple layers to it, right? Different microprocessors, right? Different microprocessors, like there are Intel and then there is AMD and all of these kind of things, right? And these will have separate instruction sets, right? And also if we have different let's say operating systems, right? In different operating systems like Windows, right? And then Linux and then Mac OS, right? All of these operating systems will store the code differently, and they will do memory management differently, right? Memory management is different, everything is different, right? In each and every particular memory management is different, everything is different, right? If everything like this is different, right, that has to be handled by every particular version of GCC. So for example, if we are installing GCC in our Windows, it would be different. Windows will be a different GCC, and then like that would be a very big problem as of now, right? So these executables you cannot run anywhere. These executables, once they are developed in a system, you have to only run it there. It's the same way here as well. But let's come to the world of Java. Now, what Java has done is, right? Let's come to the world of Java. So Java by onset, it's a pure OOP language. When I say pure OOP language, what do I mean by pure OOP? Right? When I say pure OOP language, what I mean is very simply the code cannot run without the class. That's what I mean. Now, for now, if you don't understand what a class is, that's fine. But for now, what you need to take away from this is that Java is a pure OOP language. Got it? Pure OOP language, right? But why do we use Java is what I want to understand here, right? There is a very good reason why we use Java, and that reason is we have something known as the JVM, right? Before even going to JVM, let's see what exactly happens when we use a Java file, right? When we try to compile a Java file, right? I will write some Java code here, right? Let's write some Java code here. Okay. Now, for first timers, it will look like it is all Greek and Latin, but bear with me, it's not that hard. Okay, right? So I'm going to write a class. Okay, and let's say I write the name as hello world, right? And I'm going to write public static. For people who have seen this a lot of times, it's okay, right? But for them who have not seen this, it's fine. I will try to explain you and make you understand what all these terms mean, right? For now, let's just move, right? Okay. Now, in this main, what we generally can do is we can just write like system dot out dot print ln, and then we can print hello world, right? So that is what we are having here, right? So this is our normal Java code. Cool. This is a very normal Java code. As I said, there is a usage of class here, right? Without using a class, you cannot even write a Java program. Class is fundamental to Java. Okay. Now, these kind of things you'll keep on like understand later. But what happens is, what you generally do is when you generate a when you generally what you do is, once you have written this class, right? If you named it as hello world dot java, right? What you generally do is you take this hello world dot java file, right? And then you run using Java C, right? Java C is the program that you use. So this is what is this? This is a Java compiler. Okay, this is a Java compiler, and this Java compiler will generate a hello world dot class file. Okay, this will generate a hello world dot class file. Now, this hello world dot class file will generally have, okay, this hello world dot class file is actually an executable. For now, I will call it an executable, but how is it an executable is what is the question, right? So let's see what exactly are we doing to make it an executable, right? Let me just see. Okay, yeah. So what we generally do is we take this hello world dot class. This hello world dot class is what exactly speaking, it's generating a file, right? And this file is known as a dot class file, right? Java C generates this file, right? This file will contain what is known as the bytecode. Okay, and bytecode will have certain special instructions. Okay, the special instructions are something like load, invoke, okay, and special. All of these kind of instructions are there. Okay, now what is this bytecode is that this is the biggest advantage of Java. right? This bytecode that you see here, right? This bytecode that you see, that you get, this hello world.class file, right? You can run it using, you can, what now you can do is you can run it using Java and hello world. Now this, if you don't understand, hang on with me and you will understand what I am trying to say, right? You can use Java and hello world. You don't need to put the dot class extension. It is already intended. It will take up whatever is the one. It will be able to run. Now what is this Java and what is this Java C, right? Let's go there and let's understand what they are actually, right? Before even going further, we need to understand what they are, right? Okay, so generally we have three terms: JDK, JRE, and I think, yeah, JDK, JRE, right? These are the two terms actually, right? And there is one more term that I will explain during the thing, right? So what you generally have is, okay, you generally have something known as java.exe, okay, and inside this java.exe, so this java.exe is one module. This java.exe is also known as JVM, okay. This java.exe is also known as JVM, right? And along with that you also have something known as rt.jar, okay. Now this rt.jar, what it is basically, it's basically short form for runtime Java archive is what it is, okay. It's a runtime Java archive. Cool. Now this both combined, okay, these two combined form what is known as the JRE, okay. JRE is what? JRE is Java runtime environment. Okay, okay. Java runtime environment, okay. JRE is Java runtime environment. And one more thing is that we have rt.jar. Rt.jar's main function, right, main function is that it has all the classes and interfaces of Java library. So whenever you use let's say string or anything, then you generally say that these are coming from rt.jar, okay. Now to this if I have one more box, right? To this if I have one more box, right? If I have one more box, what is that box? Let's take, okay, one second. It's a little confusing when I'm writing stuff like this. Okay, so to this if I add one more box, okay, let me just move some things. Sorry for the inconvenience, right? Okay, let's move certain things. Right. Right, I'll redraw the entire thing. It's just going to waste my time. Right, java.exe is basically our JVM, right? And then what we have is rt.jar, right? These two combined will form a JRE, right? And here what we have is that here we have this, and then here we have this, right? And now what we have is one more box. Now this one more box is one more interesting part that we are going to look into. Now this thing we have like Java P, Java C, Java doc, and all remaining jar files, right? These jar files are basically just Java archives which have more information basically, right? Java P, Java C, all of these kind of things, right? Now in this particular thing we have something known as the JDK. So this entire thing combined is known as JDK, right? This thing is known as JRE, which is Java Runtime Environment. What is JDK exactly? JDK is, very simply speaking, Java Development Kit. Java Development Kit. Now, one very big misconception that a lot of people have is that you need JDK, otherwise you won't be able to run JRE, right? You actually don't need. You don't need JDK. If you want to just run Java programs, right? You just need JRE, right? You just need JRE. If you want to develop Java programs, then you need JDK, which also contains the runtime environment, right? And so that is what you do with JDK and JRE, right? Now, the biggest one more misconception that people have is that they think Java is a compiled language. Java is a compiled language, right? This is wrong, right? This is wrong. This is 100% wrong. It is not at all a compiler. It is a compiler plus interpreter. Okay, right? Now the compilation part it does is through Java C, right? Java C will give you the bytecode. Now when you have the bytecode, it is given to this program called another program called Java, right? Java.exe that I showed you, that program, right? That program will run the dot class file, right? When this is running using something. This Java file is literally what did I tell you? It is same as JVM, right? If it is same as JVM, right? JVM, what it is doing, it is interpreting. It is interpreting the bytecode. Right? So the bytecode that you see and all, right? The bytecode, you generally don't see bytecode, right? But you can also see bytecode. I'm going to show that to you how it can be done, right? But apart from that, what you generally do is this bytecode that you have, this bytecode can be read by JVM, right? And whenever it reads a line, it compiles it then and there. And this particular thing is known as JIT, or what is it known as? Just in time compilation. Okay, right? Now this is all about your JDK, JRE, everything. But why is this useful for us to know? That why is Java so useful? The reason is that you have bytecode that is being generated. If you take this bytecode to some other system, right? If you generate bytecode in system A generated, bytecode, if you have this, right, what you can do is you can take it to system B, right, and install your JDK or just the JRE, and you can very easily run this. You can very easily run this particular system A bytecode. Do you understand how huge this is? This is so convenient that you are not now dealing with anything that is machine code. You are dealing with a special kind of code which is known as byte code, right? You're dealing with a special kind of code which is known as byte code, right? This byte code can easily be interpreted by your JVM, right? Your JVM is very easily going to interpret your byte code, this byte code. And so in any system you generate a dot class file, right? You can take this dot class file and go ahead and run that dot class file in another system. That is the biggest advantage of using Java, right? This is like the golden advantage of using Java. Okay, now are there any doubts till now is what I'm going to ask. Hello? Hello? Guys, are there any doubts? Okay, if you guys have any doubts, okay, what I will do is my team will pick up those doubts and they will go ahead and ask like put them in the public chat later, right? Cool. Okay, now right. So I'm gonna allot like 10 minutes at the end for the doubts. So for now, if everything is clear, I'm going to move on, right? So we'll move on to like why this JDK and JREs, all of these kind of things are there, right? Everything is done. Like this particular part is done, right? Okay. And we will. So I think we can go ahead and install Java, right? If that is cool with you guys. Right, I will go ahead and show how I can install Java. Right, 1 second. Right, sorry. Yeah, is my screen visible? Okay, so I will yeah, so that is the reason why Java is platform independent. Java is platform independent mainly because you can very easily go ahead and you can very well use your system, right? Because of the byte code, you can go ahead and use it in like JVM can be JRE can be installed anywhere, and then that runtime environment can be very easily used to run that byte code, and it will be able to generate the machine code related to that particular machine, right? It is so that is the main thing with Java, right? Okay, now let's move on and I will explain you how we can install Java, right? So I'm going to open my system here. So here I'm going to type in jdk.java.net, right? Okay, inside this maybe I'll go and type check JDK 19, right? This is what I'm doing. I am checking JDK 19, and then in JDK 19 I am going to this page, and then there are reference implementations. I will go and click on Java SE 18, right? Here I have the file downloaded. You can click depending on the system you have used, you can go and click Windows 10 or like whatever it is, right? You can click that and then it will open, right? So right now I have already downloaded it in my system, so I will open that file, right? 1 second. 1 second. Yeah. Okay. Is my screen visible, right? So what I will do is I will go ahead and open downloads, and I have my thing here that I have downloaded it and extracted it, right? This was the download. Let me just right. So this was the download. I will go and see this, right? This is the JDK that I have, right? what I can do is I can copy this entire thing, right? I have downloaded that and I'll copy this entire thing into my system. I'll go to C. In C, I can obviously go to program files or whatever it is, right? And I can create a new folder, right? And I can just do Java, right? This is my Java place, and I can paste it here, right? I can continue, and it will go ahead and paste the entire thing. It will take some time. Now, meanwhile, when this is happening, what we can do is I can go ahead and check the advanced. One second. Okay. Yeah, okay. So I can go ahead and check the advanced system settings. View advanced system settings. Okay. Now, one second. Let me just see if you guys are able to see everything. Window capture. Right. Yeah, one second. Window capture. I am going to capture one more device. Right. Okay. So as you guys can see, there is a hello. Yeah. So there is a system properties, right? You can actually go to this very simply. You can like you can search advanced system properties and you can go to this particular place, advanced system settings, and then you can go to the environment variables. You click on environment variables and you will be able to get environment variables. One second. Right, one second. My system is lagging. Right, one second. Yeah. Is my screen visible, guys? Hello. Yeah. So the download link to Java would be this. Sorry. So the download link to Java would be this, right? You can go ahead and get the Java there, and right. One second. Um, right. And I will add one more. One second. Right. Can you guys see my system settings there? Right. What I will do is I will copy this particular thing, this particular program files.java here. Right. Here I have JDK 8. I have bin here. Right. I will add this into my system path. One second. Are you able to see one? Let me just check. Right. If you guys are able to see the screen, right? What I basically did was I copied my entire Java download that I did into this folder called Java in program files. I created a folder and I downloaded here. And then in this I have JDK 8. In JDK 8 I have the bin folder. In bin folder, what I have done is I have gone to the bin folder. So I will go ahead and copy this particular path here, right? In bin folder, I'll copy this path. This particular path, when I copy, what I will do is I will, right, let me just check. right? Yeah, you can see this, right? So I opened my environment variables, right? You can go here by going from control panel system advanced and then there advanced system variables, or like there is many ways. You can even search on on Windows and then you can easily open it, right? On this you go and check your system. In this system variables you can go and check your path, and in this what you do is you edit this, right? In this what you generally do is you can just paste it here, the path. If you paste it here, what you can do is you can press OK, and what you generally have is you have installed Java now. Basically that's what you have done, right? Now what happens is if I open a PowerShell window, right? Let's see. Okay. uh, okay, so if I open a PowerShell window, one second. Right, is my entire screen visible now? I'm sorry, I did not know how to do this, right? I'm little sorry. Cool. So if my entire screen is visible, right? So what we can do is we can obviously now, so I'll reshare what I did basically. What I did was, one second, right? What I basically did was I went to jdk.java.net. So I'll do the same thing, right? Right, jdk.java.net. I clicked on JDK 19, right? In there I wanted Java SE18, SE8, right? Java SE8, and then I downloaded the Windows Development Kit, right? For Linux and all, it's very simple. You can just see how to run Java, how to install Java in Linux. You will be able to run. You'll be able to see, right? So now if you go to Windows 10, if you click on Windows 10, you will be prompted to download that zip file. I have already downloaded, so I'll not download it, right? So what I have done is I have downloaded the zip file, right? This is the zip file that I have. I have extracted it here, and this extraction would actually give you some name. I have renamed it to JDK8, and then I went to this PC, and then in this I just in my program files I just added Java, a folder called Java, and in that Java what I have done is I have copied this JDK8 folder. That's it. That's what I have done. Now inside this JDK8 I have gone to JDK8 and then bin, and then I copied this particular path. Once I copied the path, what I have done is simply speaking, I added it into system variables, right? So you can just say advanced systems. Yeah. So you see with view advanced system settings. In this view advanced system settings, you just go environment variables, and in the environment variables, what you generally do is you check the system path. In the system path, I have already added this. You can obviously add it. You can remove it, whatever you want to do, right? Once you have done that, and also you can also do one more thing in system variables. You can also create a new variable called Java_home, right? And the value would be before bin, something like JDK8, right? And once this is done, you are set up. You have set up your Java. The reason why you have to use Java Java_home is because like sometimes some compilers want to see whether like Java home is available or not. So some editors and some IDEs, right? So now if your Java is installed, what you should be able to do is you can run Java C and check the version, right? Yeah, you can very well see that Java C is working. See Java C -v, right? If I do -v, what is like, okay, it is showing that it is invalid flag. Why is it invalid flag? Right, okay. Right, okay, Java version, you can just do -version, right? If I do version, I would see that it is installed Java 1.8 and it is working. And in the same way, if I do Java -version, I should see that it is OpenJDK and it is 8, right? So this is how you install your Java code basically. This is how easy it is to install, Java in your system. And let's also create, a file in, and see how it works. right? So what I am generally doing is I am typing in this particular, right? Okay, so once the practice is okay, right, I will create a Java file here. Okay, I will open this particular place code dot, and then it will open it in VS Code. That is what I generally use, right? So VS Code, we can very simply use VS Code, right? I will create a file here. So this file I'll just first save. I'll save it as hello world dot java, right? So I'll save it as that. Let me just see. 1 second. It is showing. No. So if you have some other version of Java, that's fine, right? If you have some other version of Java, that's fine. Make sure that you point to the correct version as of now. If you are using JDK 11 or JDK 8, that's fine. That's okay, right? For now, you just need to use like whatever you want to install, you can install. But right now, I'm only teaching you, going and teaching you JDK 8, right? So that is the reason I'm sticking to 8, because that is the best version to teach. Other than that, I have no other reason, right? The other thing is that, yeah, I think, yeah, that is good enough reason, right? So yeah, so what I think we can do is 1 second. Right, okay, cool. Yeah, so I have hello world.java, right? What I can do is I can write a class hello world, right? In this class, I can very simply write psvm. Okay, it is not giving me public static void, right? If it is not visible, I will just go ahead and increase the size here. So I will just do public static void main, and then in this I can just do string and then args, right? And then in this I will just do system.out.println, right? And then just do hello and then world, right? And I can, now what I can do is once this is done, what I can do is I can use the same particular desktop practice that I have. I can see if Java C is installed, Java C hyphen version. Yes, it is installed, right? I can just do Java C, and then so this particular thing I'm using the terminal using control tilde in Windows. It would be in Mac, it would be command tilde, or you can also use your PowerShell, right? Here I already have the PowerShell, right? So if I use my PowerShell, let me just check. Sorry, what is happening? Right. So if I just use my PowerShell, I see that there is a hello world.java. I can also check whether Java is working. It is working. So I can do hello world dot java, right? And then I can just press enter, and now if I do ls, right, what I will see is there is a hello world.class file that has been generated without any issues. If I actually want to see the class file, what I can do is I can do java p-c, right, hello world dot class, right? What I will see, this is what is generated after compilation. This is known as the bytecode, right? It has invoke virtual, invoke special, load underscore 0, all of these kind of things. This is bytecode, right? This particular code, when you transfer to any other system, right, and you can run it, like that is the reason why Java is platform independent. The command to run it using, you know, C to check the bytecode is java p-c hello world.class, right? Once you do it, you will be able to see what is Java C actually generating. It is just generating a intermediate code that you already want to use, right? Now what you can do is hello world, right, Java hello world, and then you can easily run, right? You don't need the dot class, it is intended, right? You don't need to do that, right? And you will be able to see that it is running your hello world, right? So that is the basic understanding of, you know, Java. One second, I'm just gonna remove a lot of these things. Sorry. So right, I'm gonna remove this stream, video capture, and then this stream, and then this stream, right? So now that you have seen all of that, right, let's go back to the concepts, right? So yeah, everything, did you guys understand everything? If you did, leave a like, leave a thumbs up, subscribe to the channel, right? And we'll move on to the remaining concept that we have, right? So the remaining concept that we have is so this is the intro to Java. Now we will very quickly learn about the identifiers and all of those kind of things. What I'm going to do is, I have already pre-written some stuff. I'm going to copy this particular thing, right? I'm going to copy this particular thing, right? I'm going to copy this entire thing, so this is, so till now we have seen the introduction and like basic of Java, right? JDK, JRE is done, right? So this is done, and then we are now going to look into Java rules, and then maybe we can cover data types, so and so on and so forth, right? Okay, right, yeah. So the Java rules are actually pretty simple, right? In general, Java is kind of like a, you know, actually it is not so simple. Java is kind of like a very stringent language when it comes to rules and all, right? So I'm going to explain you some rules, and then let's go ahead. And before even explaining you some rules, I'm going to explain you, right, how, you know, like what are identifiers and all. Even before identifiers, let's see more things, right? Even before identifiers, sorry. Okay, so there are some more language rules that I forgot to write, and I'll explain you them right here, right? Okay, so some of the things is naming conventions, language rules and naming conventions, right? The naming conventions are basically very simple. Simple in the sense they are, I mean, you definitely have to follow them, otherwise it's not going to work out, right? So by default you have classes and interfaces, right? For now, if you don't know classes and interfaces, I'm going to explain them later, but for now you just have to think that you have to use for classes and interfaces, you have to use what is known as the Pascal case, okay? And so for classes and interfaces you have to use Pascal case. For variables and methods, what you have to use is something known as the camel case, right? So camel case is used to, you know, write the thing, and I'm going to quickly explain you what each of them actually mean. And for actually, like, you know, constants and these kind of values, what you generally use is something like you know, uppercase, it is an uppercase, you know, snake case, uppercase snake case, basically something like that, right? So what do I mean by all of these kind of things, like so generally whenever you name a class, what you generally write it as is like class, and then the name of the class should be Pascal case. Pascal is a very old language which defined that you have to make the first letter of the every letter in a word has to be capitalized, basically that's what they said, right? So let's say if it is hello world, both you can see that both H and W are capital, right? In the same way, if you are defining an interface, right, if you're defining an interface, you have to define it as like flying, like let's say dish, something like this, right? And this is how Java also maintains its libraries as well, right? So if you know this, then it's very easy for you to even go through the documentation and understand stuff, right? So that is the first thing. And variables and methods use camel case, right? The camel case thing is very simple. Again, camel case is the most used, right? So for variables, right, these variables are not same as your static variables. I'm going to explain you what exactly variables and methods mean, but for now what you need to understand is that variables and methods, for you generally name it using camel case. Now what is camel case? Is that you generally have a camel which has like a hump and all, right? A hump is there. So what this signifies is that whenever, instead of Pascal case, the first letter is not here. In Pascal case, the first letter is capitalized, right? In camel case, the first letter is not capitalized. Remaining letters of the starting of the word will capitalize, right? That is what camel case means, right? So let's say I want to say phone number, right? If I want to save a phone number, I'll write phone number, right? If I want to set some age, I'll do set age, right? If I want to get first name, right, I'll do something like this. I'll write something like this, right? In the same way, we have constants as well. So constants, we use uppercase. We generally go with uppercase and then snake case as well, right? So what do I mean by fully uppercase, right? Fully uppercase in the sense you would write something like max underscore value. So these are values which are constants, which should not be changed at all. You will have something like min underscore value, right? You will have something like pi, right? So you use value, like you can see that this particular thing here, there is an underscore here, right? The reason there is an underscore is that is what makes it a snake case. Okay, it's the same thing, right? Okay, yeah, okay, so it's the same thing, right? So snake case basically says that you are separating your variable names with just underscores, and these variable names are actually basically known as identifiers, right? I will move this a little bit down so that actually known as identifiers, right? Okay, so Java has something known as identifiers, right? I'm not going to write the program. I already have the program here, right? In this particular program, whatever this program that I have, right, the identifiers are those, right? I'll highlight the identifiers, right? Identifiers are those which just have one single, like they are basically any name given to anything, any program. Name in any program is an identifier. Basically that is the name in any program is an identifier, right? Right, cool, got it. Very simply, right, name in any program is an identifier. Here what we have is, let me just, right, here what we generally have is we have hello world, which is an identifier, right? Here we also have public, static, void and class. These are not identifiers. These are known as reserved keywords, which I will explain very shortly, right? These are not identifiers. The other thing that is an identifier is main, right? And string is not actually a reserved keyword. It's a name of the class. It's a class, so it is also an identifier. Args is definitely an identifier because it's a variable name. Any name, what did I say? Basically any name that you see in any program, name in any program is an identifier, right? So that is what an identifier is, right? So here system is also an identifier because it's a name of a class. Out is also an identifier because it's a variable. print ln is also an identifier because it's a function, right? So we literally have around how many identifiers here? We have 1, 2, 3, 4, 5, 6, 7. So these are all identifiers. Now every identifier generally have some rules. Identifier, these are some identifier rules basically, right? Every identifier generally have some rules, and these rules are pretty simple to follow. Once you become little experienced, you will understand that you really don't need to go through these rules, but for brevity we will understand, right? We will go and see, right? Now the examples here, what is written here? Identifiers are a sequence of characters which can only have characters from this particular character set. So what I mean is very simply that any identifier that you create, any name that you give to a class or like variable or a method or anything, should only use these particular characters. That's it. A to Z, A to Z small, 0 to 9, dollar and underscore. That's it. You cannot use anything else. That is the problem, right? So if I use something like if I use underscore dollar underscore, right? This is correct. This is okay, right? Okay. Right. If I use underscore dollar underscore, this is fine, right? But if I, let's say, use all @hands, right? This is not okay. Why? Why? Because we, this right? This is basically not a part of this character set. Right? So that is the reason this is wrong. And the second rule, again, the second rule is very simple. It says that the first character, cannot start with a digit. That's it, right? So something like this is illegal, right? You cannot say one hand as a variable name. This is illegal. This is wrong. One hand. You can basically use underscore one hand. That is correct. Underscore one hand, because you instead of a digit you are using a normal, your normal naming convention. Again, this other point is very simple. Again, you generally have no length limit, but recommended is to use length of 15 as a variable name. Sometimes they are in production, you generally have names which are very, very big, and that's fine. That's cool, because it's more easier to write code and understand code with big names rather than trying to document code, right? Name should be documenting itself, right? So, and also Java identifiers are case sensitive. Like for example, age and age and AGE and AGE, all of them are different. This is different, this is different, this is different, and this is different. All of them are completely different, right? So they are all different. And also when you say when we have something like we should not use keywords as keywords, right? Keywords. So I'm going to explain what keywords are very shortly, right? If keywords, I can explain what keywords mean, right? So so the keywords that you have, right, they cannot be used as identifiers. So something like int, right, void, all of these kind of things you cannot use as identifiers, right? So you should not use them as identifiers. Basically you cannot say something like int equal to 5 or something like that, right? This would be very bad, right? You should not write code like this. This would be giving you a compilation error, right? And the next thing that you have is that you can actually, so this is a very weird rule, but what you can actually do is you can use a predefined, predefined class or interface as a variable name, right? So something like int string equal to 10 is perfectly valid, right? Int string equal to 10, or you can say int integer equal to 5 is perfectly valid, even though these two things, even though string and integer, they are class names actually. These are class that you already have, classes that we already have, right? So this is possible, but should you do it? If it is possible, should you do it? Don't do it. Basically, that's what I will say. By convention, please don't try to use names of classes or interface to make your point, because it's not going to work out. It is going to make your life a little hell. So let's not go with all of those kind of things, and let's not do that, right? Cool. Okay, right. Right. Let's extend for 10 minutes, right? And I will explain what reserved words are, right? I have a complete page that I have already created. I'm going to copy this page, and then I'm going to briefly explain what that particular thing is, right? Right. Okay. One second. Right. Okay. So I already have created a particular, uh, thing here. So it is easy for me to explain. That is the main reason why, because there is no time, right? So there are basically 68 reserved keywords as of now in Java, but that I'm only going to explain you 53, and there is a very good reason why, because I am only so there are new keywords that have been introduced from Java 8 plus, right? I am only focusing on Java 8. This will be a good base to learn. After that, you guys can go ahead and explore more versions of Java, right? So what I am so there are only 53 reserved words, right, in Java, right? The reserved words that I'm talking about is that what you have seen here, basically whatever you have seen that keywords cannot be used in as identifiers. So these are some words that you cannot actually use as identifiers. That means identifiers in the sense that you cannot use them as names, right? Cannot use them as identifiers, right? You cannot use them as identifiers, right? So that is what reserved words are. So reserved words are very, very important in a system, right? You also, if you have ever learned C or C++ or any other language, you will generally have some reserved words, right? So in Java there are 53, Java 8, as of Java 8 there are 53 reserved words, out of which there are keywords and reserved literals, right? One is 50 keywords, and reserved literals are like true, false, and null. So it is not actually 53, it is 3, literally just 3, right? So that is one more thing, right? In these keywords we have like used keywords and unused keywords. The used keywords that we have are 48, right? And the unused keywords that we have are 2. This is one is const and goto, right? This const has been completely replaced by something known as final, and goto is not used at all. Let's not use goto and const at all. These are there, but you should not use them. Don't use them at all, right? That is the first and foremost thing, right? So I'm briefly going to go through the keywords that we have, right? The keywords that we generally have are data types, and then byte. In data types keywords we have byte, short, char, int, long, and then we have in floating point we have float, double, and then boolean. And in flow control we have if, else, switch, case, default, while, do, for, right? All of these keywords you cannot use them as variable names. Again, here break, continue, return, and all, right? In exception handling as well, right? We use some particular keywords like try, catch, finally, throw, throws, assert. If all of this is new to you, it's fine. I'm going to explain exception handling in one of the class, right? So that we will cover there, and we will know what are these particular things meaning. And in modifiers we have something like public, private, protected, static, final. I will very briefly explain you what these mean, but not in today's class. And then there are stuff like abstract, synchronized, native, transient, volatile, strict FP. And particularly speaking, strict FP should be avoided. It is not something that you can use, that you should use. Even Java tells not to use. And the reason is that it is only used for one and only one purpose, right? It is only used to make sure that your particular, your class follows IEEE 754. That's it. That is the only reason why strict FP is used. IEEE 754 is a format for storing your decimal numbers, right? And so that is the reason why strict FP is been removed. Now Java has completely shifted to IEEE 754. So this is redundant now. This is not useful, right? And abstract and all, we will learn about abstract. Synchronized is related to multi-threading. Maybe we might not learn this. And then native is related. So with native you can run code like C and C++ code, right? There is some code that if you want to run using C or C++, you can use native. There is something known as JNI, Java Native Interface, and then that you can use. And then you have transient. So this is not going to be discussed. And then volatile and synchronized are little related, but maybe this will not be discussed. This might be discussed. We will see, right? And these are your object related keywords like new, super, instance of this, right? So new can create a object, super can refer to superclass. So if you don't know all of this, it's fine, right? It's fine. I will explain you everything, right? And then there are miscellaneous keywords which are void and enum. And in this void and enum, you basically for used void when you don't want to return anything from a function. And even if you don't know what a function means, I'm going to explain you all of those kind of things in upcoming classes. And enum, I'm going to explain what this is, right? In total there are literally 48 keywords that you need to use, and you might not remember everything, but what you can say is um, basically you can obviously keep on using them, and one fine day you will remember everything, right? So that is what these are the keywords that are there, right? So yeah, so I guess today's class, right, we can stop it here. And maybe from tomorrow from tomorrow I will explain you things like data types, right? And right, I am going to explain you things like data types. This is done. So things like data types and operators, right? In tomorrow's class we will explain, I will explain you everything regarding that, right? So and I'll also share you this notes regarding that. And guys, if you found the content good and you feel like you have actually gained some knowledge today, you can go ahead and subscribe to the channel. And also you can obviously try and you know ask some doubts. Now I'm going to be here for another 5 to 10 minutes. You can go ahead and ask me doubts, whatever it is. That would be very nice if you guys, okay, can ask me doubts. That would be very nice. Right. Yeah, I'll share the notes. I'll definitely share the notes. I can see that some people are asking me to share notes. I will definitely share the notes. I will also share the code that I wrote, although it was very simple code. Hello world, anyone can actually write the code. That is very simple, right? But yeah, I'll share the codes. I'll share the code, notes, everything, right? Um, yeah, so I'll wait, and I'll see if anyone is asking for some doubts. Um, yeah, you guys can start asking doubts if you guys want to, right? I understand. Hello. What do you mean by GCP? Do you mean Google Code particular thing like Google Cloud Project is what you mean? GCP for coding. I'm not sure what you're trying to, refer to actually, right? Yeah, I know. I know GC. Yeah, hello. Guys, I'm here. You guys can ask me doubts if you want to, right? So these are very basics. Yeah, okay. So in a very short manner, I would say JDK, JDK, JavaScript. So JDK is basically like um, how I can say is Java C. Basically, it is uh, Java C, Java Doc, and JRE, right? And JRE itself is just java.exe and rt.jar. That's it, right? And rt.jar is runtime.jar. All the things that you require in runtime would be there, right? So those kind of things are there in rt.jar, right? Yeah, and you can install JRE separately, right? And you can also install rt.jar separately, right? Sorry, not rt.jar. You can install JRE separately, right? And you can only run Java files, right? You can only run Java bytecode using dot class, right? As I showed you in the video before, right? You can just use you can just take some dot class file from some system, and then you can run it in some other system, and that other system need not even have JDK. So yeah, yeah, I think certificate is provided. Certificate is provided. Uh, like, but condition is that attend all the classes, right? So that is the condition, right? Attend all the classes and then like see all the lectures. Like that is the main condition, right? Yeah. Um, as for astonish, right? So for a Java full stack, right? Java full stack, you actually require core Java, right? And then maybe in some companies you use advanced Java, right? But you definitely require something like a Spring framework, right? You need to understand, REST APIs and all of those kind of things. A little bit of OS, a little bit of CN, right? Because Java is very closely related to the system, and also SQL is definitely going to help, right? Even if you don't know OS and CN, you will cover all of those kind of things in, your engineering, right? And you can obviously expect that you can do SQL, and you can also learn NoSQL and all of those kind of things. Yeah, but all of these kind of things will, come from experience. But right, these things are not so hard. With HTML and CSS and JavaScript, you become a front end, right? uh, right, you become a front end engineer. But if you want to become a full stack Java full stack, right, you basically use front end and also the above things that I told: Java, core Java, and then core Java, and then Spring, and those kind of things, right? Spring, SQL, and then NoSQL. So those kind of things you need to learn, right? It depends on how much you are willing to learn and how much you are putting your efforts, right? So that is what I would say, right? If you guys have any doubts, you can also ask in the WhatsApp group that you have already registered for, right? And you can obviously check there. Yeah, and yeah, and I will share my notes. I will share the GitHub link on the WhatsApp group. Everything will be there. The GitHub link and the share, like notes, everything would be available there. And tomorrow we will start with data types, and how these data types are used, and how these particular things are used, right? Data types. I'll explain what public static void main means, right? So yeah, what are the program need to learn for backend? So with for backend, you generally don't, so most of it is conceptual, right? So backend developers, what you need to understand is you need to for backend you need to very well understand OS, and then you understand CN, right? Not entirely, but a lot. Like you need to understand DSA, right? You need to understand like hash maps and all of those kind of things. And also you need to understand SQL, right? Something like SQL, and then database concepts, right? Before even SQL, you need database concepts, right? Database concepts. In database concepts, you have like normalization, right? And then tables, and then SQL, all of these kind of things, NoSQL, right? So backend, and then you need to learn about REST APIs, right? You need to know about HTTP, you need to know about TCP. So backend is not a straightforward thing. And obviously using a language, right? Using a language like, let's say, Python or Java, right? Or C or anything like that. Now you also have C and C++ as well, but the problem with C and C++, they are not so easy to develop web application. So you should mostly probably stick to Python, Java, or Golang, right? So these would be my recommendations. Or Node is also very good. I mean, that's what I would say. So something like this, right? Okay. Yeah. Attendance, I don't know. You might have to ask in the WhatsApp group, or you can ask further doubts in there. And if you actually liked the content, right? If you like the content, and if you have enjoyed whatever you have seen, right? You can go ahead and like, share, and subscribe to this channel, CodeSprint, right? And you can obviously, if you see that you want other people to as well understand more stuff from you can share the link for this. Something like React Native, right? React Native is not equal to backend at all, right? It is not used in backend. So React Native is a front end framework, before learning, React or, React native, I would suggest to learn JavaScript, right? So this is very, very important. Like if you don't know JavaScript, right, learning, React, JavaScript, okay, so basically React without JavaScript is like a human without a soul, right? Something like that, or you can say something else as well, right? So you basically have nothing if you don't learn JavaScript. That is the main thing. JavaScript, if you learn, then you would be very well understanding React and React Native. React Native is used in the front end for React Native is used in the front end for mobile development, right? Mobile development. So front end basically, right? Thank you team so much. Start from basic INF. Yeah. Thank you, Shubham. Yeah, I will try to make sure that this is more interactive. As of now, I cannot speak with you guys, but I will try to be as patient as possible. My PowerShell is showing some error after entering D colon. Oh, okay. Yeah. So D colon is used actually for D colon is used to so D colon you cannot enter D colon because I have a D drive, right? If you have a D drive, then you can enter D colon, right? It's basically drive letter and then colon, right? You can go to that particular drive. So I entered D colon and then it went to that particular place, right? So yeah, that is one thing. So D colon is for drive, right? Drive. So if you don't have a drive name colon, uh, so I'm not an expert in Spring Boot, right? Spring, I would say Spring is basically a backend framework, right? It provides you Spring basically is a backend Java framework, right? Which provides you with which provides you a lot of things actually, right? Which provides you with REST API, methods and other stuff, right? Right. So it's basically a framework, right? You can go and read about Spring online. I have not used Spring ever, so I don't know. But generally, something like Spring or Spring Boot, you would mostly use for, you know, stuff like whatever, like creating, backend, having a backend and, trying to create something there. So you can also use Node and all, right? You can also use Python Django, Python Flask, but Spring is something that is being used in most of the, things and yeah. Yes, you can. Avnesh 219, you can go ahead and start coding directly on VS Code, right? In general, it will ask you if you like if it will ask you from marketplace to download extensions as well, right? If you want to write code in Java, right, you can use VS Code or you can use Eclipse and whatever you want to use, you can use, right? And yeah. The PowerShell is not PowerShell is something that is related to Java, Windows, right? It is not exactly something that is related to, uh, you know, PowerShell is Windows specific command line tool actually. That's it, right? If you like, you can like take a small crash course on using PowerShell, right? Yeah, I see guys that there are very very less number of people left in the stream, so maybe I'll take a leave today, right? And from tomorrow I can explain you guys more stuff, right? And tomorrow I'll start with data types and all. So let's see how good that is. Cool. Yeah. I'm gonna take my leave. If you guys have any doubts, go ahead, check with the team, CodeSprint team on WhatsApp, and you can. I'll share my notes there. I'll share the repository there. Although there is only one particular piece of code that we wrote, right? Thank you guys. Thank you for staying back and listening to whatever I've said. Thank you.